optimal conditions that may plague this late add-on. For example, the new construction is constrained by the structure of the original house and the proximity to the neighbors' houses. And perhaps there's a shortage of high-quality building materials, and it's possible that you've lost the blueprints and can no longer afford expert builders. In addition to making a much larger and much less efficient house, this variability makes it likely that the new addition will not be as good as the original. So to sum up, not all multilingual brains are created equal. There's incredible variability. But despite this variation, multilingual brains are still much more similar to one another than they are to monolingual brains. One of the biggest differences between monolinguals and multilinguals is that multilinguals must build mechanisms for keeping track of their separate languages. Think back to my trilingual student. Every time she speaks English, she has to suppress French and Spanish. And when she switches to one of those, she has to suppress the other two. How in the world does she do this without constantly mixing up her languages? Well, the answer comes back to a familiar brain region, the frontal lobe, or more precisely, the prefrontal cortex in the frontal lobe. The prefrontal cortex, or PFC for short, is constantly at work when we use language. It has to keep track of what was just said, and it must monitor what to say next. And on top of that, it also has to suppress information that's distracting to the task at hand. This suppression is hard enough for monolinguals, but multilinguals must work extra hard, because when they're speaking one language, their other language or languages must not get in the way. Evidence for language co-activation and suppression in multilinguals comes from many different lines of research. Let's go through 4 of them. For starters, let's take our case of bilingual aphasia. One distinctive but not uncommon problem of bilingual aphasics is pathological mixing of languages within an utterance. It's called pathological mixing to set it apart from voluntary mixing. Voluntary mixing is perfectly natural. The best known example in the US is Spanglish, but there are many other mixes too. For example, there's also franglais, a mix between French and English. And here's one you might not know, svorsk, a mixture between Swedish, svenska, and Norwegian, norsk. Pathological mixing is where an aphasic can't control swapping L1 and L2 words within a sentence. And sometimes they're not even aware of doing it. That's interesting, but here's an even more peculiar symptom. In some rare cases, there's pathological switching of languages across sentences. Again, when this is voluntary, it's quite natural. It's even got a name. Linguists call it code switching. But for some bilingual aphasics, they can't help themselves. So an aphasic from Switzerland, for example, might alternate between fully grammatical and complete sentences in French, German, and Italian over the course of an entire conversation. By the way, this phenomenon connects back to something we've discussed before. Remember spoonerisms? You know, saying a half-warmed fish instead of a half-formed wish? Spoonerisms provide support for language models stating that an utterance or utterances are conceptualized and packaged before we utter them. Well, I want you to think about pathological code switching as further evidence of that. Okay, so what's going on in the brain to produce this type of uncontrollable switching? In 2000, Franco Fabro and his Italian team of neurolinguists published a landmark case study of a patient who demonstrated pathological switching of his 2 languages, Italian and Friulan. Friulan is a Romance language spoken in northeastern Italy. The patient frequently alternated entire sentences between Italian and Friulan, even when speaking to people who didn't understand one of the languages. In this particular case, the patient was aware that he was making these switches, and it caused him great distress. After his symptoms got even worse, and he started having difficulty walking and driving, he went to the doctor, who suggested an MRI to look for structural abnormalities in his brain. The results showed that he had a large tumor growing in the left inferior frontal gyrus. The damage was not quite in Broca's area, which explained why he could still speak fluently in both languages. So where was this damage? It was an area just anterior to Broca's area, located in the PFC's executive control network, which is important for neural inhibition. In this patient's case, damage to the left PFC not only made it impossible to stop alternating between languages, but it also produced more general deficits in social inhibition. For example, one clinical observation was that the patient grew very fond of telling dirty jokes, even in quite inappropriate situations. Since this study, there have been other cases of structural damage to the left PFC and pathological code switching. And just as with Fabro's case study, these patients also demonstrated more general deficits in social inhibition. This has led many researchers to conclude that this is not a problem specific to language, but rather a more domain general problem of executive control. We'll come back to this later. A second line of evidence for the co-activation of multiple languages comes from research on neurotypical bilingual brains. In one simple but creative approach, the Spanish psycholinguist Albert Costa exploited the fact that some bilinguals have many shared vocabulary items across their two languages. These overlaps are called cognates in linguistics. For example, take Spanish-Catalan bilinguals who have an unusually high number of cognates. In Catalan, the word for cat is gat, and in Spanish, it's gato. Costa had fluent Spanish-Catalan bilinguals look at pictures of things that either had cognates in the two languages, like a picture of a cat, or didn't have them, like a picture of a table, which is taula in Catalan and mesa in Spanish. The task was to name the objects in either Catalan or Spanish as quickly as possible. The prediction was that if the mental lexicons of Catalan and Spanish were both active when trying to name a picture, bilinguals should be slower to name objects that had no cognates, like table, than ones that did, like cat. And that's exactly what Costa found. He interpreted this finding to mean that when bilinguals are searching for lexical items for a particular meaning, both languages are simultaneously active. And this activation can facilitate or interfere with naming, depending on whether the phonological forms are similar or different. The third line of evidence for multi-language co-activation considers the flip side of cognates. For all bilinguals, there are some words that randomly sound similar across their languages but have completely different meanings. For example, the Russian word marka means stamp, while the English word marker means, well, marker. What happens when a Russian-English bilingual hears the first few syllables of those two words? Do they activate both meanings in their heads momentarily? That was precisely the question asked by the psycholinguists Viorica Marian and Michael Spivey in a 2003 eye tracking study. Remember eye tracking? That's where eye gaze is recorded by a mini camera which captures the moment-to-moment timing of what people are thinking. The experiment studied Russian-English bilinguals as they listened to a Russian speaker referring to different objects in Russian. So picture a computer screen that has an image of a stamp on the left side and a dry erase marker on the right side. When subjects heard the Russian word for stamp, marka, their task was to press the side of the screen where the object was located, in this case, the left side. On the surface, this should be a pretty straightforward task, right? But the eye gaze pattern suggests something more nuanced. When the stamp was paired with a marker, bilinguals looked at the marker a third of the time. This means that there was competition between the phonological forms of the two words, marka and marker. In contrast, when the stamp was paired with a competing image that had a totally different sounding English translation, like a candle, the bilinguals were 3 times less likely to look at the competitor. It's worth emphasizing that the experiment was done entirely in Russian, so there's no reason for English to be active in the first place. Despite this, it wasn't possible for the bilingual subject to totally tune out the irrelevant language, even when it was disruptive. This is a great finding from the lab, but it's always nice to see results generalized to the real world. So let me share a little anecdote from home. Occasionally, when my bilingual wife uses numbers in English, she says 7 when she means to say 9. Why would she do that? Well, in Japanese, the word for 7 is nana, and that sounds kind of like 9. The fact that she does this, usually after a long day of work, suggests that both of her languages are always active and that it's not easy to keep them apart. Okay, before we turn to the final piece of evidence, I want to share another interesting example of this co-activation of languages. Most bilinguals are what we call unimodal bilinguals, meaning that both languages are in the same modality, like Japanese and English. But the sign language researcher Karen Emery has studied a different type of bilingual, a bimodal bilingual. These people not only use two different languages, but two different modalities, like someone who's bilingual in English and ASL. For these bimodal bilinguals, there's a fascinating and surprisingly common phenomenon called simultaneous code blending. That's when a person speaks in one language, like English, but simultaneously signs in another, like ASL. And remarkably, this happens even when bimodal bilinguals are speaking English to monolingual English speakers. Now, remember what you learned, that ASL is not just a pantomime version of English. Far from it. It's its own distinct language. So this is some of the most direct and compelling evidence that bilinguals simultaneously activate multiple languages when they communicate. So we've considered evidence for language co-activation from bilingual aphasics and also experiments on regular old multilinguals. The final line of evidence comes from neuroimaging studies exploring how languages are activated and deactivated in neurotypical brains. The neural mechanism for this process has been dubbed by the neurolinguists David Green and Jubin Abutalebi as the bilingual language control network. In addition to the left PFC, which we've already discussed, the network involves other areas outside of traditional language network, like the inferior parietal lobe, cerebellum, and the thalamus. But the one I want to focus on is the anterior cingulate cortex, or ACC. The ACC is a subcortical brain structure involved in error detection and conflict monitoring. Neuroimaging studies have shown that the ACC is heavily used in bilingualism or bilinguals when monitoring which language is most appropriate for a given communicative context. Interestingly, this region is most active for low proficiency multilinguals, presumably because they are the ones who are most likely